Hi guys, welcome you all to my channel Explore Edu to Teach.
Topic that we'll be learning in the concept of CMOS inverter is going to be transfer characteristic of CMOS inverter. This is a very important graph. This graph tells it all about CMOS inverter. How does it work? Okay, this graph is very important. Understand this graph very well. All this graph pictures will be uploaded on my Instagram page. The links are given down in the description box. Please check it out, and if you like the Instagram page, please follow me over there. Also, this entire notes will be uploaded on my Telegram group. The link of my Telegram group is given down in the description box. Join my Telegram group for all the notes of all the topics on this subject. So please check it out. So basically, we have this CMOS inverter graph in which we have the input and we have the output. So we have the input voltage, we have the output voltage, and finally we have this graph. Okay, so basically what happens is that in this graph you have 0, VTN, VDD by 2, VDD minus mod VTP, VDD, and so on the Vout axis. So you need to understand one thing, that this graph speaks it all about CMOS inverter. So when the input voltage is between 0 to VTN, okay, or my input voltage is less than VTN, if you see, when my input voltage is very less to VTN, okay, what happens is that the NMOS, okay, in the CMOS inverter, the NMOS is off and the PMOS remains in linear region. So if you see over here, when my V input is very less than VTN, my NMOS becomes off, my PMOS remains in linear region, and now if I talk about NMOS is off, right, that means the resistance is very high and hence it is off and there is no current flowing through it. Therefore, the resistance of a NMOS or a PMOS is given as R on is equal to 1 by Kn into VGS minus VTN, and the R on is also equal to 1 by Kp into VSGP minus mod VTP. So what happens is that when my input voltage is less than VTN, my NMOS remains off, my PMOS remains linear, and the resistance of a NMOS and PMOS is given as 1 upon Kn VGS minus VTN, and for a PMOS is 1 upon Kp VSGP minus mod VTP. So this is basically the transfer characteristics of a CMOS inverter. Now when my input voltage becomes greater than VTN but is smaller than or equal to VDD by 2, okay, basically it should be smaller than VDD by 2. So when my input voltage is greater than or equal to VTN but smaller than VDD by 2, the PMOS remains in linear region and my NMOS becomes on, which was off earlier, and it goes into saturation region. It is clearly mentioned over here. Again, when my input is VDD by 2, okay, so what happens is that my PMOS and my NMOS both remain on and in saturation region. Understand? So when my input is exactly equal to VDD by 2, my NMOS and PMOS remains in saturation region. And if I talk about the V input value, that time it's given as VDD minus mod VTP plus square root of Kn by Kp into VTN upon 1 plus square root of Kn by Kp. And if Kn is equal to Kp and if my mod of VTP is equal to VTN, I can say that my Vin is equal to VDD by 2. So basically when I say, right, when my input is equal to VDD by 2, how is that? Basically here, the Vin has this entire big formula. So when I take certain assumptions that my Kn is equal to Kp and my mod VTP is equal to VTN, in that case my Vin becomes equal to VDD by 2, which is the ideal value, and this is the practical value. Okay, now when I say my V in becomes greater than VDD by 2 but smaller than VDD minus mod VDD, okay, what happens is that my PMOS goes into saturation region and my NMOS remains in linear region. Finally, when my V input is greater than VDD minus mod VTP but is smaller than VDD, okay, so when it is between this region, right, my NMOS becomes linear and my PMOS becomes cutoff. So this is very important and this is what you should know. So this diagram is very important. You should know at what input values my different regions of operation of MOSFET. That is very crucial. So once you understand for this value of V input, this is my condition or my state of MOSFET, drawing this diagram becomes very easy. From this particular diagram, there are questions asked in the competitive exams like GATE and so on, and also in the university exam wherein they'll ask you to draw the transfer characteristics of a CMOS inverter and explain. So this diagram will be uploaded on my Instagram page. Please check it out over there. Links in the description box. Also, the entire notes will be uploaded on my Telegram group. You can download it from there. Please join my Telegram group as well. So if you understood this particular video, do not forget to like, share, subscribe to my YouTube channel. Also follow me on Instagram and my Telegram group for all the updates and all the notes. Thank you so much.